Hi everyone. So in lesson 101, we will be using the vector space properties learned in the last lesson to help us solve geometric problems with elegant solutions. So let's start by taking a look at example 1. Given triangle ABC such that x and y are the midpoints of AB and AC, so let's mark that, x and y, respectively prove using vectors that xy is parallel to BC and equal to half the length of BC. All right, so here is the line segment xy. In this question, we are required to prove that xy is parallel to BC and also the segment xy has half the length of BC. If we turn this into a vector question or vector relation, well, two vectors that are parallel to each other will have similar direction. And xy is half the length of BC, or we can say that the vector xy is a scalar multiple of BC by a scalar multiple of 1/2. Okay, so we're going to show or try to show this is true. So here is our proof. Let's see. So for vector xy, I can actually write it as vector xa plus vector ay, right, as a sum of two vectors. And then, because I want to make some connections between this smaller triangle in the diagram to the bigger one, where we can relate BC, I can find a relationship between, some of these vectors. So vector XA, if I look at this carefully, it is half, because X is a midpoint, right? So half of vector BA. And the vector AY is half of the vector AC. Because of this, I can factor out the scalar multiple and write this as BA plus AC. If I take a look at the diagram now, vector BA plus vector AC gives me the resultant of vector BC. Thus, I can confidently say that the line segment xy is indeed half the length of BC, and the line segment xy is parallel to the line segment of BC, proven. Example 2. If OP is the median of triangle AOB, express OP in terms of OA and OB. Okay, so let's refresh our memory of what's a median. A median is a line that connects a vertex of a triangle to the midpoint of its opposite side. So if I say let P be the landing point of the median, then the line segment AP and PB should have the same length, okay? And here we want to show that, theoretically speaking, expressing OP in terms of OA and OB require us to write it as a linear combination, right, of OA and OB. So the linear combination lambda and mu are real numbers, okay? So let's see how we can prove this. I know that I can write the vector OP relating it to OA as OA, vector OA plus vector AP. Or I can also express the vector OP in terms of OB as OB plus BP. Like that, okay? Let's call these equations 1 and 2. So I do have OA and OB in there. I don't have AP, BP, like I don't want that to be part of my result. So it looks like, what if we try to combine the two equations first and see what happens? So let's add equations 1 and 2 together. I have 2OP equals OA plus OB plus AP plus BP. Not bad. And I noticed that, the vectors AP and BP, they are related, but they have opposite directions, right? But they will have the same magnitude. So I can say that since BP vector is actually the vector PA or the negative of vector AP, then 2OP is OA plus OB plus AP minus or plus negative AP. Well, AP minus AP will give me a zero vector. In other words, 2OP is now OA plus OB. And so the vector OP can be written as a linear combination of half OA plus half OB. And indeed, this relationship has a special name. It's actually a property called a vector median property of the triangle. Okay. Okay, next. Let's take a look at example 3. In a parallelogram PQRS, the points M and N are on the sides PQ and PS respectively, as shown in the diagram, given that the point M divides the side PQ in the ratio of 5 to 2. So it's basically like this, the longer side versus the shorter side. Find in which ratio does point N has to divide side SP that MN is parallel to QS. Okay, lots of information is given. So here I know that MN is parallel to QS and the point N divides the line segment SP in the ratio, let's say L to K. Okay, let's label this as L and the longer side K. So let's see. Well, let's relate, some of the line segments that we know. Let's start with MN as a vector. So MN is MP plus PN as a vector addition. I also want to relate this to, the larger diagram because we have some information about QS. So let's express MP using the line segment QP or the vector QP that goes in the same direction. This must be 5 over 7 as a scalar multiple of QP. What about Pn, vector Pn? Well, it is K over K plus L, the total length of PS, like that. Okay, so let's call this our first equation. What else can we say about, what we have? Well, we know that MN is parallel to QS. And we know using vector properties that if two line segments are parallel to each other, two vectors are parallel to each other, I must be able to write them as scalar multiple of each other. So let's let MN vector equal to lambda times QS. Okay. And QS itself is QP plus PS. Okay, not too bad. So now we do have two vector representations for Mn. We can make them equivalent to each other. I can say that 5 over 7 QP plus K over K plus L PS is equal to lambda times QP plus PS, which means that lambda QP plus lambda PS is equal to the left side. This allows us to inspect right, because we say that equivalent vectors have the same direction and magnitude. For this equivalency to be true, that means that 5 over 7 QP should equal to lambda times QP, and K over K plus L should equal to lambda, right? This allows me to say that 5 over 7 is equal to lambda, and then I can sub this into the second relationship. And so I have 7K, if I cross multiply, equals to 5K plus 5L. 2K is equal to 5L. And so K must be 5. Oops. And L must be equal to 2 for this relationship to hold true. Okay? As a result, we can say that the point N divides the line segment SP in the ratio 2 to 5. That's it.